Hi guys, this is the second page of the quadratic packet, and we're going to solve each equation here. And I want you to notice something. It says solve each equation here, but there's a y and an x. So like usually we would solve for y. How do you solve a quadratic if there's no number that it's equal? Because up here, it was equal to 0. So it was very kind of obvious we're getting x by itself. What do you do here when there's an x and a y? Well, when you solve quadratics, it is assumed because there's interchangeable vocabulary, like I said, that solutions are the same things as zeros or roots. And remember, those are the same thing as x-intercepts, but x-intercepts are just notated a little bit differently. So all we're going to do is set each one of these equal to 0 and solve. That's what we're going to do. And this first problem here says to solve it by square roots. Mrs. Bruno did not call it square roots when we did it in class. I just said solve for x, which means the same thing, get x by itself. You're able to do that because as opposed to question 6, where there's an x squared and an x, question 5 just has an x. So I want you to think for one moment first, what does this graph even look like? If you think about it, this graph would be to the right 3 and up 8, and it would be smiling. Narrower than I drew, but that's okay. It's just a sketch. Where will it equal 0? Down here. I'm going to get imaginary solutions here. Sometimes it's nice to just have a little thinking moment to think of if your answer is making sense, and that's how you can do it by considering the graph, especially on this problem. So what we're going to do is we're going to subtract 8 from both sides to get x by itself. And I get 2 times the quantity, x minus 3 squared. I'll divide both sides by 2, which will give me negative 4 equal the quantity x minus 3 squared. And now I'm going to square root both sides. Now don't forget, when you square root both sides, you get plus or minus. So I'm going to get plus or minus. And what is the square root of negative 4? Well, that negative tells me that there's going to be an I, and the square root of 4 is 2. So plus or minus 2i, and that equals x minus 3. To finish up, I need to get x all by itself, so I'll add 3 to both sides. So I get 3 plus or minus 2i. Now this is okay for math people to write it this way, but if you want to know what are the two answers, because I'm always looking for two answers, it's 3 plus 2i and 3 minus 2i. And that's how you solve by getting x by itself, or what they call the square roots. And we do that when it's easy to get x by itself. Now, on this particular one, they're telling me to factor in 0, which does tell me that it does factor. But a lot of my students, I do believe, would do quadratic formula here. Why would they want to do quadratic formula? Because the 2 in front, they don't even want to mess with guessing and checking or AC method. So first, let's talk about methods to factor. You could guess and check, or you could AC method. Now, if you guess and check, there's only one way that this 2 can break down. You can have a 2x and an x, and that is the only way. Now, there's multiple ways for a negative 10 to break down. It can be 1 and negative 10, or 2 and negative 5, or flip the signs. Now, when you get good at guessing and checking, you know some little life hacks. You can never put a GCF into a parenthesis. So I cannot put the negative 10 here because that would put a GCF, which would mean the 10 would have to be over here. Now I'm not going to put the 10 there either though, because that's going to give me 20. And notice I'm trying to get to 1. That's going to be too big. So the 1, 10 is not it, which leaves the 2 and the 5. I cannot put the 2 here. That would put a GCF there. So the 2 is going to have to go here, and the 5 will have to go here. Now, I need to look at the outer and the inner to figure out how I can get to positive 1x. I'll need the 5 to be positive, and 2 times 2 is 4 to be negative to get there. Once it's factored, and you have 2x plus 5 times x minus 2 equals 0, we do the zero product property. What does that mean? Well, this is a quantity times the quantity equal to 0. How can I get 0? Well, either this guy has to equal 0 or this guy equals 0. Now, the first one on the right is obvious, x equals 2. That would make that 0. But what would make the guy on the left 0? You might have to do a little math. 2x plus 5, how does that equal 0? Well, you would subtract 5 and divide by 2. And the other answer will be negative 5 over 2. So that's if you did the guess and check. If you did the AC method, remember we don't like the leading coefficient, so we will change the problem. That will be x squared plus x minus 20. This factors relatively easily when you make your list for negative 20, and we're looking to get a positive 1. This gives me a negative 1, so I'll just change the signs, and that will give me a positive 1. And that leaves me with x minus 4 and x plus 5. But you can't forget, you changed the problem. We took the 2 away, so now we must put the 2 back in both parentheses. Look for GCF. There's a 2 here. That would be 2 times x minus 2. Throw that GCF away because you put it back twice. You only need to put it back the one time here, and that will be 2x plus 5. There's not a GCF there, and then you finish the problem like you would do the last one. So that's how you factor. Nothing wrong with doing quadratic formula. If you want to do quadratic formula, you will get numbers that simplify nicely. And that would have told you why it would have factored. It would have worked out nicely to get the same answers. Okay, complete the square. We complete the square when b is even here, and it doesn't factor. Obviously, 1 can never give me 14, but what I can do is I have this even b, I can draw the boxes. I have x squared. I have negative 14x, which means each side would get 7. Of course, that'd be 7, so I had to draw so many of these little things, which will put 49 in the corner because 7 times 7 is 49. So this guy is closest to the perfect square, x minus 7 squared. But when I'm looking at that square, that has 49 in the corner, and I clearly don't have 49. I only have 1. So to get from 49 to 1, I will have to subtract 48. And those will be equivalent. And we're trying to solve that, which means we remember to set it equal to 0 and solve. Again, if you're thinking about what this might look like, it's going to the right 7 and down 48. So it'll be way down here. We are going to get 2. We are going to get 2 real answers here. So let's make sure we don't get any i's. We'll add 48 to both sides. We'll square root both sides because now we're just getting x by itself, because we took the 2x's and turned it into 1, which looks like the problem right above it. And we get x minus 7 is plus or minus the square root of 48. Square root of 48. That looks like it can be simplified, and it can. What perfect square will go into 48? Well, there's actually a couple of them that do. 4 goes into it, but that's not the biggest one. The biggest one that we want to pull out is the 16. So x minus 7 is plus or minus. 48 is the same thing as 16 times 3. Well, the square root of 16 is 4. So x minus 7 is plus or minus 4 square root of 3. To get x all by itself, you'll just add 7 to both sides, and you get 7 plus or minus 4 square root of 3, which means the two answers are 7 plus 4 square root of 3 and 7 minus 4 square root of 3. Those will be really nasty decimals, and we're going to practice with calculators a little bit later this week. And what that also means is, remember when I drew that sketch over here? It means if I would have used my calculator and done second calculate zeros, that those two would have given me really nasty decimals in my calculator. But if I would type that in my calculator, those nasty decimals would match. Okay, question 8. Question 8 says to use the quadratic formula. 5 only breaks down to 1 and 5, so it does not factor to get me 2. It says to use the quadratic formula, but I never would have used the quadratic formula here. Why? Because think of how easy this is to draw. X squared, 2 x's, 1 on each side. So that's an x. I'm going to want to complete the square. That's an x minus 1 square. That would be 1 in the corner, but I have to get to 5, so I'm going to add 4 more. So sadly, they told us to do quadratic formula, but I think you should have completed the square. I will do quadratic formula in a second to show you, but let's take a look at what it looks like this way. What will the graph look like? Well, we'll go to the right 1 and up 4. So I think I'm going to get imaginary numbers, because where does it equal 0? Down here looks like imaginary. So let's see what happens. Get x by itself. Subtract 4. X minus 1 squared is negative 4. Square root both sides. There's that -4 square rooted again. X minus 1 is plus or minus 2i. Get x all by itself by adding 1, 1 plus or minus 2i. But we will do quadratic formula since they did tell us. Remember that a, b, and c are necessary, and you have to know the formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And we identify, a is 1, b is -2. Be really careful with signs there, guys. And c is 5. You need to be able to plug these in correctly. I do a lot of it in my head. The only thing I write down number-wise from the formula is the -4. I'm going to do negative b in my head. -2 is +2. Plus or minus square root. I do b squared in my head too because, guys, remember, b squared is always positive. I do write down the -4 part. That does not mean 4 minus 4 because I'm going to have to take that times a times c, which is 5. I do that in my head as well. All over 2a, which is 2. Type this part in your calculator or your brain. What's 4 minus 20? That's 2 plus or minus 4 minus 20, -16 over 2. Square root of -16, 2 plus or minus, that's 4i over 2. And we finish quadratic formula with the love of math, 1 plus or minus 2i. So either way it works. I do think completing the square would have been a little quicker, but that's up to you, and it does say to use it there. So that's the page 2 of the quadratic packet.